So yeah, let's have some fun with the Nintendo, which is a fine piece of hardware, even today. Um, so what is this thing that I'm going to be talking about, I guess? It's the latest in 1980s music technology. This is controlling a Nintendo's sound, like the sound stuff that the microprocessor works, or the sound stuff that makes or the sound stuff that is in the microprocessor, like compiling down to the assembler through JavaScript. So this piece of hardware right here is what we're going to be running everything on. And there's no trickery involved or whatever. It's actual Nintendo programs like running. Just want to make, some people are like, hey, it's like, you have some like crazy thing, but no, it's real. Like when I first started this project, the goal was to make it easy to write music for a Nintendo. And that's been done a lot in the past also. There's trackers, which are basically sequencers that you can use to like sequence music on Nintendo itself, or they have programs that will output like the actual sound like of the Nintendo or emulate the sound chip. But I wanted to do it a little bit differently. I wanted to do it using JavaScript because JavaScript and whatever, right? So why? A lot of people, why? Why do you want to do this in JavaScript? To me, it's self-evident. JavaScript's awesome, right? It's a language that I really like. But the whole project itself, like, I really like this sort of music, this chiptune sound. I grew up in the 80s playing a lot of Nintendo, 4 or 5-year-old, like playing Super Mario Brothers all the time, or whatever, Zelda and all those games. I think over that amount of time, like there's a nostalgia factor that like those tunes, like I didn't pay attention to the music, but they're ingrained in my brain now, and so I love it. I don't know how else to explain it. I think that probably a lot of people have that nostalgia factor. They look back to their childhood and whatever they did a lot or played a lot as far as like video games or music or whatever, they gravitate towards that. So I think that's a big thing. But the JavaScript part is because of browsers. Now, I knew that if I could get something working in JavaScript, I would have a path to get to the browser. And that's important because once you do that, if you provide a low-level JavaScript API to this sound engine, you can create, or you can give the opportunity for people to create fancy UIs for trackers, sequencers that are all web-based. And I think that's really cool. And I actually wanted to do that, but I think this is like the first step to that point. So that's primarily why. And also because it's a lot of fun to hack on a Nintendo with JavaScript. It's crazy. So the next question is like, how is this working? Because it seems sort of magical to have a Nintendo in JavaScript and stuff. So to get this to work, I had to read a lot about how the microprocessor works, about how the 6502 assembler like is written, because I did not go to school I didn't graduate with a computer science degree, so I have like no idea how this stuff works, like, right? It's just all magical to me. But I read a lot and like I learned a lot of assembler, which is crazy. Like no one should ever have to do that, right? But then along the process, like I wasn't just reading about like assembler and like how the Nintendo works. Like I read a lot about music too, because a lot of that stuff, like I had no idea how it worked. And then throughout the whole process, like I would go like write assembler or write JavaScript and figure out how this stuff was going to work and figure out the API and all that stuff. And then what I would end up doing was once I had something working, I would write music and try to like figure out like, does this make sense? Does this work? Does this API, like, no? And then I'd go back and like be like, oh, that part's stupid, like get rid of it. And so I'm at a place now where it's like there's some stuff that I don't like, but I think the API is decent enough to present. So what I have here that I'm going to demo in just a little bit after I kind of get through like the basis of what this is is a assembler sound engine. So what happened was I was like, oh, I want to make like this thing make sound. So I went and I read a lot and figured out how to do that with an assembler. I made a square channel like beep. It just kind of went beep, you know, like square channel, which I'll demo kind of in a second. Then after like I went through these tutorials on like these NES developer forums, and at the end of the tutorials you kind of have a basic working sound engine in assembler. But assembler is really difficult to work with, and you know, it's not very fun to write music in assembler. Just doesn't like, I don't know, it's assembler. So once I had that though, it was easy to write a JavaScript API to that so that it could compile down to what a song would look like in assembler. So really quickly, this thing has, let's see, how many are there? 5? Yeah, 5. 5 channels, 2 squares, a triangle, noise, which is just random noise, and a sampler, which I did not do the sampler because it takes up a lot of memory and I didn't really figure out how it works. So I'm just going to be working with these for now. So the square channel, the features that it has is duty cycle, which I'll show a demo of it, because a lot of this stuff, like, you can't really visualize it. I guess you can visualize it if I had like an oscilloscope, but I don't. But it's better just to listen to it, so we'll listen to it in a second. But these are the features. Didn't get frequency sweeps working, but here we go, and I'll demo the square. Can we get the demo thing going? Okay, so this is the little file system thing on the Nintendo that I have going. Okay, so here's a square. This is going to play a C note, and it's going to go through the octave range of a C note on a square channel. And that was just doing like, you know, a for loop with a number or something, and just passing that into like, you know, song.square, and it's just an array of notes, and it plays it. All right, I gotta reset this sucker to get back. Oh, one other thing that I kind of skipped over, duty cycle and volume envelopes. So duty cycle, it kind of spaces out like, or narrows the, did we get this back? Oh, sorry, can we get this? Yeah, back, sorry. It spaces out or narrows like the actual square, how it looks, and it creates a different sound. So just to kind of, this is the same note, same octave, just manipulating the duty cycle of the square channel. Okay, so I got square stuff working and it was beeping. The next thing I did was like, actually, like once I got the square channel working, I made that beep, then I went to the sound engine and wrote the API to it. And then I wrote this thing, which it's just some notes and changing octaves, and this is just what it sounds like. This was literally like the first thing I wrote besides the beep. So it doesn't sound awesome at all, but. All right. Okay, cool. So, that was the first thing I wrote, and then I started implementing all these features. Volume envelopes, if you're not familiar with them, like imagine like a note is broken out into like a bunch of frames, and you have the ability to say like on frame 1 of the length of the note, make the volume 0, and that on a scale of 0 to like say 10, 0 being off, 10 being the loudest. So 0, it's off, and then you gradually increase it, like frame 1, 1, and then keep going 2, 2, 5, 5, 10, and then it's the loudest. So then you have created a fade-in effect. So you can manipulate these notes with volume envelopes to create like blip effects, like echo or staccato or fade-ins, fade-outs, all sorts of things. I don't think I have a fade-in demo, but let's see. Oh, one other note is like square channel is the only one that can do that. So with triangle, you have the ability to turn volume on or off. So you're pretty limited. I don't know why this is the case, but you can either say like, hey, this is on, it's just binary, on or off. And you can use volume envelopes with them, but it'll just interpret any value that's not 0 as a 1. So triangle, it's made for like bass sounds, for the lower octaves, really high octaves. It's the like flute sounds that you hear in like Zelda and stuff. So here's an example of I don't remember. I think this is just the same as the square. It's just going through the octaves of C. So there we go, triangle. Noise. I don't really know how to explain this because it doesn't really map to music very well. It sounds like drums. Sometimes you can get like certain ones sound like hi-hats or snares or like bass drums and stuff. But for musical notation, I didn't know actually how to represent this. So this was one of the problems I had. But here's like the full noise range that you have. So then with like those sounds, you can create drums. And this is kind of a really dumb, like simple drum beat. Okay, so techniques. So all the channels on here are monophonic. So you can only play one note at a time. You can't make chords. So what people would do, composers of the 80s they would fake it. Like they would make arpeggios and speed them up super fast, like increase the timing of the note, or speed the tempo up. A lot of like the Japanese games and stuff, they were just written like if you listen to a lot of video game music, it's just written monophonically. Some of the Commodore 64 people would use the arpeggio technique. But let's go through some songs before I go forward. So I was having trouble like I was trying to like do some 80s music for JSConf given the theme. So I did Billie Jean, just the bass line though, because the square doesn't really sound, or I couldn't get it to sound super good. So this is just the bass line. It's really simple. Let's see if it sounds decent. That's it. That's the whole song, pretty much. And the square channel would be like that, burp, burp, but yeah. Okay, so let's go. So then I kind of went through like a bunch of songs. Like I tried a bunch of different types of music before I talked to like actual people that compose music, and they gave me some pointers. So I was like, oh, I like Slayer and I like Raining Blood. That must be an awesome song to do, but it's not really, because it's actually really boring. This is the whole song, pretty much. It's just drop D over and over again. And there's that little part in the middle, but okay. So Slayer was boring. Like a lot of, I mean, drop D over and over again does not sound good on the Nintendo. So I was like, okay, I'm going to like take a crack at rewriting a Super Mario track. So I came up with this. So that one actually worked out really well. I was much happier with that than Slayer. And yeah, so then after talking to some people and showing them what I had, though, I was kind of like, yeah, here's the problem I'm having. Like, all these songs have chords, and it usually doesn't sound good. And there's a couple cases where I did get chords to kind of sound good, but I don't know, like what I did, instead of doing the arpeggio technique, because I could almost never get that to sound okay, is I was actually talking to my brother, and he's like, just use power chords, because you have two square channels, so you can just use the two, and that kind of worked, but it still didn't seem right. But then I was talking to a composer friend of mine, and he was like, you should check out the, and I forgot what they're called now, but these Bach pieces, BWV 847, I think, is the prelude in C minor, and 851 is D minor. I didn't finish these, and they're kind of long, so I won't play them all, but they're really great because they're mostly monophonic, so they map really well to the Nintendo. And I have volume envelopes, so I can make them play at staccato, which is what like Glenn Gould and stuff plays them at. Okay, it's more of that. It's just, yeah. So yeah, here's really quickly. This is just the first couple bars of the D minor one. I think the timing's off, but so those work really, really well because they're monophonic, and since there's no chords, it's just. It makes sense, right? I can use, if you're like reading music, you can use like for the bass clef, you can just use a triangle channel, and then if you have like notes up top, you can use square or even mix them up or whatever. Okay, great. So that's kind of like what I have. So moving forward, though, going back over, I guess, to here. Is the future. Like, what do I want to do with this? I have this API, I have this module that's on NPM that can take JavaScript and produce these songs in the end. It's mostly JavaScript. There's this last piece. The assembler itself is actually C++ assembler. But I think that even can be moved to JavaScript, and there's already people that have JavaScript assemblers for the Nintendo, so it's not that much of a jump to get there. So I think we can get a NES assembler in JS that's one module that you can just say, hey, here's some assembler, give me a Nintendo program, and that will be awesome. And then I think also with this API, we can build web UI tools that, since you have an assembler in JS and you have this stuff that I wrote in JS, you can say, here's the sequence of sounds, like click a button or whatever, it builds it, it outputs your assembler, it assembles it, gives you a actual Nintendo program. And then you have things like people have written emulators in JavaScript for Nintendo, right? I mean, I'm sure we see these things pop up on all of the news sites and whatever over the last 5 years. So you have your whole build environment in JS, and you just need to piece it together and get it in the browser, and we can have this really awesome, authentic sounding thing to make 8-bit music. So yeah, I don't even know how much time I have because this thing's not going, but I can keep talking about this stuff. But okay, cool. So let me go back to the why of how I got started into this stuff. So I had previously written graphical stuff in for this, and I gave some talks like writing slides and stuff on the Nintendo itself, and that was super hard, and I didn't do a very good job at like the graphical stuff. Like I had a lot of problems with it, and it was a lot of like stuff that was hacked together. And then I can't remember where it was, but I was giving a talk, and the AV person came up to me and they said, "Oh, are you going to need sound to the Nintendo?" And I thought, "Oh no, I won't need sound. I don't have any sound." And I was thinking about it a little bit later, and I was like, "Why don't I have sound? Like, why didn't I read that part about sound?" So I thought like, "Oh, I should go back and figure out how sound works." And it was just that curiosity like that in the back of my mind, like, "Oh, how does this work?" and stuff. So I went back, and there's a lot of stuff that's written about the Nintendo that's out there, but there's not a whole lot of practical examples. So finding like this sound tutorial and kind of standing on the shoulder of giants and like taking this stuff that these other people have written and using that as a basis for like saying, hey, like I could just write a JavaScript API to this, and I know JavaScript well enough that I can expose this so that other people can use this stuff. And yeah, so I got to that point, and it was actually way easier than all the graphical stuff. The sound stuff was a piece of cake compared to the graphical stuff. And I think like a lot of this stuff is still relevant today. I mean, you have bands like Anamanaguchi that actually use like a Nintendo in their set or like in their music. They use it as an instrument. It's an instrument that has these channels that you're able to manipulate sound and get like a real authentic sound. And there's actually a game that for Nintendo that was released like a couple months ago called Star Versus. And you can buy this game for like $40 or whatever, and they give you a real cartridge, like a real Nintendo cartridge. And that is so cool that people are still hacking on it and selling games and stuff. So I think this stuff is really awesome. And so yeah, I want everybody to just like, you know, if you're interested in this stuff, like, I don't know, hit me up and talk to me, and we'll, you know, geek out about Nintendos and building musical stuff. And cool. Thank you.